All right, so this is your warm-up from today where you're graphing e to the x. The very first problem says graph y equals e to the x. We're going to make a table of values. Notice it says containing at least 3 coordinates, okay? So I'm going to ask for some help. Make my xy table. That's a terrible x, isn't that? All right, what's the value for x that you guys want to plug in?
-2. 40.
40. Let's plug in -2. When I plug in -2, we type that into our calculator. Can someone tell me what is the y value that I get, Chris?
1.353352832.
That's not
Not
right.
1.
Oh, 0 point. Okay, that changes things. 0.353. Can we all agree on that?
0.135.
Oh, 0.1353. Okay. 0.1353. Okay, what's another value you want to plug in for this one? 0. Okay, let's plug in 0. What is e to the 0th power? 1. Because anything raised to the 0th power is equal to?
1.
Very good. What's another value for x that you want to plug in?
2.
Okay, Devin wants to plug in 2. What is e to the 2nd power?
7.3891.
Okay, so now I'm going to zoom in because it's going to make it a little bit easier for me to graph. So at 0, I had an x coordinate, oops, let me turn my pen on, of 1. At 2, I'm a little bit off my graph paper up here at 7 point something. Oop, I put that at the 1 spot. Erase that. All right, then what was I at -2? 0.1 something?
-2 is 0.1353.
Thank you. So there's my little curvature. What is occurring at the x-axis? What is this spot called?
Asymptote.
An asymptote. Is it a vertical or a horizontal asymptote? Very good. It's a horizontal asymptote. And that's going to affect either my domain or my range. Which one?
Range.
My range. Okay, so what is the domain for e to the x? All real numbers. Very good. Now what about the range?
Y is greater than 0.
Very good. Y is greater than 0. Notice that 0, what is he controlled by? What is my range controlled by? Did we just talk about anything on the graph? The asymptote. Very good, Devin. That 0 is controlled by this asymptote right here. Okay, so then all of a sudden, I gave you on the bottom this transformed equation here. And then once again, I asked you to make a table. So let's make another table. Let's do a horizontal table. It's another strategy. Ooh, it's tricky, right? Okay, so then I saw Miss Emma was plugging in some really big values, and she's like, oh my gosh, these are huge. So then I'm like, okay, maybe let's try in some negative values. So if a strategy for you on your test, if all of a sudden you're like, oh my gosh, this is a huge y value, try some other ones. So what's the next value that we'd like to start with?
-1.
Negative 15? Negative 13?
It doesn't
-1.
really matter.
-1.
It's like 13.
Let's do -1, okay.
I have that one as well.
-1, that's a nice value. Why am I saying that -1's going to be a nice x value to plug in?
-2.
It's going to equal a whole number, but what's causing it to equal a whole number?
The +1.
The +1 in the exponent. So what's the y coordinate for an x value of -1?
-2.
-2. -2, okay. That's a nice value. What's another one you'd like to plug in? Okay, we want to plug in 0. If you plug in 0, what do we get?
-8.8.
Okay, that all of a sudden got really big, -8.73. So let's plug in a smaller value. So Devin, you had said -4.
No, I didn't.
Oh, somebody had said -4, my apologies. Okay, if we plug in -4, what is our y value?
About 1.801.
At 1.8, let's just say that, okay? So now I'm going to go to graph it. So at -4, I was at 1.8 approximately. So we're about, oops, gotta put my pen on, right here. What was I at 0?
-8.873.
Okay, so I was off the graph. And then we also plugged in -1, and what was my lovely nice number?
-2.
-2. Okay. All right, so then if we start to plot this, it looks like this. It's a pretty nice one. Where do I have a horizontal asymptote in this problem? The 2. Did you notice on your XY table you got awfully close to the 2?
Actually, we get on the 2 instead.
Okay. So then, one of the skill sets from Unit 1 that I had you practicing in your project was all about transformations and the ability just to look at an equation and recognize what transformations were occurring. So let's have one person say one transformation, then another person say another one. So Miss Besaw, what is a transformation that you saw occurring?
It moved up.
Okay, where do you see that it moved up 2 units?
You mean like on the equation?
Yes.
2 at front.
The 2 in front, something being added or subtracted to that equation. It also happened to be your what on your graph?
Horizontal asymptote.
Very good, that horizontal asymptote. All right, Miss Besaw's got one of them. What is another transformation that occurred to this function? What is another one? Mr. Chandler. Very good. It reflected over the x-axis. And where do we see that? What part of the equation causes it to do a flip, a reflection? Yes, Mr. Patterson.
-4 times.
That
e to the
negative. Very good, that -4. Does the 4 do anything to our function? When we multiply e to the x by 4, what does multiplied by 4 do? Mr. Patterson's already helped me out. Mr. Fomby, what does the 4 do?
It stretches the equation.
Good, so it stretches it. It's a vertical stretch by a factor of 4, okay? Now I'm seeing one more part to the equation that we have not used yet. Let's use a different color. I'm seeing this x plus 1. What type of transformations are the ones that are connected to x's in a function? I've already got you, I've already had you. Matt, are you volunteering? Okay, so let's think about it. What kind of transformation have we not talked about that would be connected to an x in left and right? Oh, if it's x plus 1, it's a deceiving one. Does it move to the left or to the right? It moves to the left. Very good. By how many units? By how many? By 1. Look at how much information we got just by looking at its equation. So what is the domain for exponential functions? What about this one? What is his domain? Were you limited by any x values, Sydney?
No.
No, so then what's the domain?
All real numbers.
Very good. All real numbers. You can plug in any x value you want. Now, what about the range? What about the range of this function? I already got you. You were helpful. Lizzie, what is it?
Y is less than 2.
Very good, guys. Y is less than 2. This is your warm-up for today. Are there any additional questions on your exponential graphing? Yes, Maria.
Is it y is less than 2 or y is less than or equal to 2?
Do we ever touch 2 on an asymptote? No, we don't. Because it's an asymptote, you see how it's that dashed line? Do you remember with inequalities, how whenever it had a dashed line, it was never or equal to? That's the same concept for an asymptote. I never ever actually touch it. When we were talking about rational functions, remember how I talked about the Mr. Matthews wall? You never cross it, you never ever touch it. You can't actually ever equal those spots.
I hid it.
You hid? Yes, Daciana.
How do you get y is less than 2?
Where does y is less than 2 come from? So if we look at this graph here,
No.
you know, Devin, you can explain?
Yes, I'm pretty sure I can.
Okay.
Because 2 is like the highest point,
Very good.
the high point of our graph.
Great
So
explanation.
everything else is beneath 2.
Very good. Everything is beneath the 2. Do we ever try to jump here? Do we ever go above that asymptote?
I didn't know believe that.
I don't believe
I
so.
wasn't trying to go that far.
Very good. We're all, everything below him. Does that help, Daciana? Very good. Any other clarifications I can provide at this time? Go ahead, Sarah.
Are there any like vertical asymptotes?
There are not vertical asymptotes for exponential functions, but the very last concept that you will actually do is graphing logarithmic functions. And logarithmic functions are the inverse of exponential, so they will have vertical asymptotes because the exponentials have horizontal. Okay? Yes, Rachel?
Will asymptotes ever be like decimals?
Will asymptotes ever be decimals? They can be decimals. They can be decimals, because what if I had given you a vertical shift of 1/2? We only shifted up 1/2 units. What if I randomly decided to shift you up square root of 2 units? So it could be decimals if I choose to make them decimals, okay? Other concerns, clarifications? All right, great. So you are now going to place these warm-ups in the middle of your table. So I'm going to collect these so I can look at some of the data points and figure out where we stand with this content.